All right, so we got cut off there, but if our epicenter was at the North Pole, the waves could move all the way through the Earth. They're going to radiate out from that focus point below the surface, and anywhere on Earth can detect them, except what we call a shadow zone. And that's caused by the outer core. So our P waves and S waves can travel through most material. If it's solid rock, it all moves pretty much the same speed. But the outer core is liquid, and it causes the waves to bend if they're P waves, or be completely repelled if they're S waves. So our red ones are the S waves. They stop when they reach the outer core. The black ones are your P waves, and they're actually able to move through the outer core, but they bend or refract as they move through. So what it creates is an area on Earth. There's a couple points on Earth that wouldn't detect the actual earthquake. And if you notice, this is what a seismograph looks like. It's the reading. So you have a little, it's sort of like almost like a heart monitor. So you have, it's normal, normal, normal. Earthquake occurs. Okay, so now you've got a P wave. Okay, it's normal, normal, normal. Then the S waves are following. So notice that the P waves actually get there first. So let's go back and talk about that a little bit. The P waves are moving compressionally. So they move like a slinky back and forth. They just kind of smush together, or clap, if you will. So that's your compressional waves. They move much faster because this is an easier motion to do. S waves are moving more like a snake, up and down like ocean waves. And they are a lot slower. So they are the ones that don't go through, they're the ones that don't go through the liquids because of the way they move there. So that is where you want to keep in mind when you're studying. P waves move faster, they're the first to arrive. S waves slower because they can't move through liquids, and they're moving up and down. So if we were looking at a graph, this is a graph of how they move. So this is the P wave moving through the mantle, up, it slows down a lot, but it's still able to move through the liquid outer core and then through the solid inner core. And here's our S waves. They're moving through the crust, up, here's the mantle, up, stop, they can't go any further, outer core. Just to keep that in mind as you're studying. The other thing you want to keep in mind are the different instruments that we use to actually study earthquakes. The first one's a seismometer. That's what detects it. To find the epicenter, you're going to need 3 different seismic stations providing you with information so that you can figure out exactly where that point is, the center of damage. The Richter scale measures the magnitude of an earthquake, and that's the intensity. Well, not the intensity, it's the actual energy released from the earthquake. The Mercalli scale measures intensity, which is pretty much just the damage the earthquake causes. So earthquake P waves are one thing to keep in mind, the damage is something to keep in mind, and the different parts of the earthquake are all things you want to keep in mind when you study it. And now we kind of brushed on to the different layers of the earth, and I just want to go ahead and touch base on it. You've got the crust, mantle, core. If you really want to be specific, then you have the lithospheres, that outer rigid portion, and then you have a little of the upper mantle in there, and then the asthenospheres where convection's occurring. Then the mesosphere is part of the mantle, then you have the outer core, which is liquid, and then the densest portion, the inner core. So just keep that in mind. Crust is rigid and brittle usually. Mantle's where convection occurs. Outer core is liquid, so no S waves, and inner core is the densest layer. It's the hottest, most densest layer. As you're going deeper, heat increases as well as pressure.